So here is another question. So it is given express minus 39 as an 8-bit binary number in sign magnitude 1s complement and 2s complement form. So before doing all that, first we have to represent plus 39. So first we have to express 39, splitting it into different parts with powers of 2. So we can write it as 32 plus 4, 36 plus 2 plus 1. 32 plus 4, 36, 36 plus 2, 38 plus 1, 39. Okay. So 32 is 2 to the power 5, 4 is 2 to the power 2, 1 is 2 to the power 1, 2 is 2 to the power 1 and 1 is 2 to the power 0. Okay, this. Now we have to represent the binary number, so the different weight positions 2 to the power 7, because starting from 2 to the power 7 because it is a 8-bit binary number. Power 7, 2 to the power 6, 2 to the power 5, 2 to the power 4, power 3, 2, 1, 0. So these positions, they will have 1 bits, remaining it will be 0. So 2 to the power 5 there will be a 1, 2 to the power 2 there will be a 1, 1 and 0, 1. This. Remaining all positions there will be zeros. So this is the binary representation of plus 39. Now this is the MSB bit, which is the sign bit. Okay, as it is 0, so it represents a positive number. Okay, now if we have to represent minus 39 in sign magnitude form, then this sign bit, it will become 1. Okay, the sign bit will become 1 and remaining bits, they will remain unchanged. So 1, 0, 1, 0, 0, 1, 1, 1. This is minus 39 in sign magnitude form. This is plus 39 in sign magnitude form. Okay, so the first one is the sign magnitude method. Okay, this 101 00 111. Next is the 1s complement form. So in the 1s complement form, we'll write the binary representation of plus 39, which is the same as in sign magnitude form, that is 0, 0, 1, 0, 0, 1, 1, 1, same as in sign magnitude form. Now minus 39, it is the 1s complement of the binary representation of plus 39. So we'll only invert the bits of plus 39. 0 will become 1, 1 will become 0. 1, 1, 0, 1, 1, 0, 0, 0. Okay, this is the 1s complement representation of minus 39. Okay, 1 1 0 1 1 0 0. Okay, 1s complement. Next is 2s complement. So 2s complement is we have to add a 1 to the LSB of the 1s complement form. So this is the 1s complement of minus 39. So we'll write it here 1 1 0 1 1 0 0 0. This is the 1s complement. We'll add a 1 to the LSB. So we'll have 1 0 0 1 1 0 1 1. Okay, this is the 2s complement. Representation of minus 39. Okay, now you can also do it with the shortcut method, where suppose we write the sign magnitude representation of plus 39, which is the same, okay, in both the cases. So suppose we write plus 39, which is 0 0 1 0 0 1 1 1. Okay, so we'll start with the LSB position and we will move until we arrive at the first one bit. So here also the LSB bit itself, the first bit itself, starting from the LSB, it is 1. So we'll keep it as it is, copies as it is, and the remaining bits will take the 1s complement, or will invert their positions, that invert their, invert them. That is, 1 will change to 0, 0 will change to 1. So 0 1 1. So we have 1 1 0 1 1 0 0 1, same as this. Okay, same here also. This is the 2s complement of minus 39. This is the shortcut method. Okay, same. So we'll keep the starting bit until we arrive at the first one bit. So here the first bit itself is 1, so there is no need to do anything. We'll simply copy the first one bit as it is, and the remaining bits we will invert them. That is, change 1 to zeros and zeros to 1. Okay, so this is the 2s complement of minus 39. Okay.